This is the help video for the study guide Unit 6 review cycle, Part 1, 6.1 through 6.5 on ALEKS. Coming here for this question, the best way to actually answer this is to take the time and draw this. So if we have a parallelogram, draw a parallelogram. Rhombus, draw a rhombus. Square, draw a square. And then you answer the questions. So all sides congruent, that's not the case with the parallelogram. 4 right angles, nope. 2 pairs of parallel sides, yes. Rhombus, are all sides congruent? Yes, by definition. Do you have 4 right angles in the corners? No, although it does have a right angle in the middle, but the right angle here means corners. Does it have 2 pairs of parallel sides? Yes. A square has all sides congruent and all right angles, 2 pairs of parallel sides. For this problem, the true and false, it's best to have the quad family tree. So here is a parallelogram and then a parallelogram. If you have all equal sides, it's a rhombus. If you have 4 right angles, it's a rectangle. And then if we have both qualities, a rhombus and a rectangle, it is a square. Now, when you keep this family tree closed, then answer the questions. Every quadrilateral is a rectangle. And that's not true because there are other quadrilaterals here. So this one's false. Every parallelogram, so it's saying every parallelogram is a square going top to bottom. That's not true. Every rectangle with 4 congruent sides is a square. So if a rectangle has 4 equal sides, it does become a square. Every square is a quadrilateral. That's a true statement. So keep the quad family tree close when you're doing this. So number 3, we look at the diagrams and you answer the questions. Marked all that apply. It says which figures are rectangles. Only figure C is a rectangle because it is a 4 right angles in the corners. So that's figure C. Which figure applies to a parallelogram? Well, B, because opposite sides are congruent. That's the second of the OCDs. And all rectangles are also parallelograms. Which one's a square? None of the above. This one is a trapezoid. Again, draw yourself little pictures: square, parallelogram, trapezoid. A square has 2 pairs of parallel sides, all sides congruent, 4 right angles. Parallelogram only has 2 pairs of parallel sides. A trapezoid has 1 by definition. That's what makes a trap a trap. Question 5, very similar to the previous one. Use the quad family tree. Says the sum of the interior angle of a convex polygon is 540. How many sides does it have? The fact that it says poly means your n is unknown. And so you ask yourself, is it an interior or exterior? That's your first question. And it's interior. And then your second question, is it a sum or a 1? And it is a sum. So the sum of interior angles, sides minus 2 times 180. So we go sum interior angle, sides minus 2 times 180. And in this case, the 540 goes here on the left. And minus 2 times 180. And then you solve. Number 7. Convex polygon has 5 sides. Find the value of x. This is really easy if it were a triangle. For example, if that's x, and that's 40, and that's 60, you would simply take it away from 180. Why? Because all triangles add up to 180. So the question here would be, what would be the sum of the interior angles? Sides minus 2 times 180. Find the sum, which is 3 times 180 here. We get 540. Now that you know what the sum is, you simply add these numbers up and subtract from not 360, not 180, but you subtract from 540. Why? Because all convex pentagons add up to 540. Find the measure of each interior and each exterior angle of a regular 15gon. So this is 2 equations. 1 interior angle, sides minus 2 times 180 over sides, and 1 exterior angle equals 360 over n. In this case, the 15 is the n. So you put 15 in there and there. Over here, we put 15 going this way. What's important to know is that whatever this angle is, the interior, and whatever this angle is, the exterior, they add up to 180 degrees. One interior, one exterior will always add up to 180 degrees. If below is a parallelogram, it's important to mark what you know is true. What you know is true is the diagonals bisect each other, which means these 2 red segments are equal. These 2 green segments are equal. And of course, you have parallel sides, which means you need to watch out for armpits of the Z going both ways. So right here, if we wanted to solve for x first, we would simply say that this segment here JKLM, we know that JN is equal to NL. So 3x plus 2 equals 11, and you solve for x. Going this way, it asks for the angles. Rather than just look for the individual angles, I'm just going to find everything possible just out of habit. So I have armpits of the Z going this way, so if that's 32, this is 32. I have armpits of the Z going this way. So if that's 44, this is 44. I'm going to add 32 and 44. And I get 180 minus 76. That means this is 104. That would make this 76. This is 104. And this is 76. So it asks for NJK. NJK, you already have that. It's 44. That's why I recommend you just find all the angles. Because if you just find all the angles, pecking off the particular ones are very easy. And NKJ. NKJ, that's the 32. It says below it's a rhombus. Find the measure of the angles. Trace the diagonals. The diagonals meet at right angles. That's important. The diagonals also bisect all the corners. So if that's 39, this is 39, this is 39, this is 39. And then you have yourself a right triangle, which means something like angle 4 is going to simply be 90 minus 39. And it's 51, 51, 51, 51. Taking a look here, let's color code what we have. We are told that JN is 2x minus 1, and KM, whole thing, is 3x plus 8. We're also given that NKJ is 57. NKJ right there is 57. We're being asked to find L to N, which is right here, the yellow, and NLK. NLK, which is this angle right here. Step 1, things before algebra. Things before algebra. So we know this. We know that the red JN times 2 equals the blue KM. The red is half of the blue, or the blue is double of the red. It's easier to work with blue double of the red. There's your thing equation. Now, solve for x. X equals 10. Now, just because you get a whole number doesn't mean it's correct, so it's important to plug it in and see if it actually correctly states that. So Jn is 2 times 10 minus 1. Of course, that's 19. Km is 3 times 10 plus 8. That's 38. And is 19 half of 38? The answer is yes. So we ultimately want, it says right there, Ln, which is the same. So that's going to be 19. All right, now the angles in a rectangle, a couple things you need to watch out for. One, every corner is a right angle. 2, because all 4 of these pieces are equal, 2 equal sides, 2 equal angles. 2 equal sides, 2 equal angles. So keep in mind you have a bunch of isosceles angles here. So if that's 57, this would be 57. You have armpits of the Z. This is 57, and then to get this angle here, it's simply 90 minus 57. We're getting 33. Things before algebra. This is similar. Things before algebra. This is really important to do this page accurately. You don't want to go back several times. So for this one, step 1, make sure your coordinates are correct. So that's 0 right there. We are told that J is at 1, 3. Always get your coordinates right on the diagram. K is at 4, -4. L is at -1, -5. And M is at -4, 2. We're going to answer the following questions to determine if it is a rectangle, rhombus, a square, or none of these. So step number 1 says we're going to find the slope of JK and then the slope of a side adjacent to JK. That means next to. So it doesn't matter whether we do this one or this one. I'm going to do the one down below. The slope of JK and then the one adjacent. So slope, make sure you do this accurately. It's going to be y minus y over x minus x. Okay, JK, y minus y, that's 3 and -4. So that is 3 minus -4, and then notice 1 and 4. Double negative makes a positive. That's 7 over -3. Then we go this way, make a template. Y minus y over x minus x. I have -5 and -4, -1, and 4. Double negative makes a positive. That's going to be -1 over -5 and positive 1/5. Okay, so the first thing we've established is that these are not opposite reciprocals of each other. They do not multiply to -1, so it cannot be either a rectangle nor a square because there is no right angle there, no perpendicular lines. Now, we're going to find the length of JK and the length of its side adjacent to. So there is your template. And JK, that's going to be 3. X's go first generally. I'm going to go top to bottom, 1 and 4, 3 and -4. Make sure you do this accurately. -1, I recommend you circle the points, and 4, -5, and that is -4. Check your work. That's -3 squared. That's 9. That's 7 squared. That's 49. And we're going to leave this under the radical sign, root 58. Here, that's -6 squared. That's 36. Double negative makes a positive. That's what -1 squared. That's 1. This is going to be root 37. So, because adjacent sides are not congruent, it can't be a rhombus. So, it is not a rectangle. The slopes do not multiply -1. It can't be a rhombus because adjacent sides are not congruent. Can't be a square because it's neither a rectangle nor a rhombus. So, the answer is it's none of these. So taking a look at this last one, let's give an example of which it might qualify as one of those so you can see how that would work. So first, always put your coordinates where they belong. And W is -1, -1. X is 6, -6. Y is 1, 1, and Z is -6, 6. So taking a look here, we're going to do the slope of WZ, which is this red, and then a slope of a side adjacent to it. And it doesn't matter which one you do, as long as it's adjacent. So y minus y over x minus x. Y minus y over x minus x. So W to Z, my y's on top, -1 and 6. X is down below. -1, -6. This is going to be -7. Double negative makes a positive over 5. So it's -7/5. Then we find the slope adjacent. Adjacent, we are going to do z to y. Y minus y over x minus x. So that's going to be 6 and 1, -6 and 1. That's going to be 5 over -7. Now, watch very carefully. They look like they're opposite reciprocals, okay? But they're both negative. So -7/5 times -5/7 does not equal -1. Watch out for that. That does not mean it's perpendicular. This one, we want distance. So we make a distance template. WZ WZ are numbers. We're going to go -1 and -6. And then -1 and +6. That's x minus x, y minus y. Something adjacent, that's going to be yz. So x to x, 1, -6. 1, +6. Double negative makes a positive. That is going to end up being +6 minus 1, that's 25. And -7 squared, that's 49, which is √74. Double negative makes a positive, that's 7, so that's 49, plus that's -5 squared, 25. They're both √74. So what we have going on here is it can't be a rectangle because they didn't multiply to -1, but adjacent sides are equal. So it is at least a rhombus, can't be a square.